Warning: Thermite is an extremely hot incendiary. Fire safety protocols must be in place. Greetings, fellow nerds. The most common and best thermite is the famous iron oxide and aluminum thermite. Most videos featuring thermite use this type, and we ourselves have made it before. But there is another type of thermite which substitutes chromium oxide for the iron oxide. The result is a thermite that generates chromium metal rather than iron. To make it, we start with 56 grams of chromium 3 oxide. It has this nice green color and is actually used as a pigment. Now the stoichiometric ratio with aluminum is 14:5, or 2.8:1. So for 56 grams of chromium 3 oxide, we add 20 grams of aluminum powder. Shake it up thoroughly to mix it, and we can then go outside to test it. As usual, I'm going to light this with sparklers wrapped in some magnesium ribbon, which was very reliable for lighting iron-based thermite. Okay, let me add the thermite. That's a little sloppy, but oh well. Now we light it up. And it's... well, shit. Looks like the magnesium-wrapped sparklers weren't hot enough to ignite it. I'm going to have to try something a bit stronger. Okay, I've removed the wasted sparkler, and now I'm going to add in 8 grams of iron-based thermite on top. Since the iron-based thermite is quite hot in of itself, I'm hoping it'll be able to ignite the chromium thermite. And there we go. Looks like it's working this time. The reaction is much slower and more tame than the iron-based thermite. What's happening is the chromium oxide is reacting with the aluminum to form chromium and aluminum oxide. This is very similar to the iron thermite reaction where we used iron oxide instead. Looks like the reaction stopped before going through all the chromium thermite. I'm going to try again, but this time I'm going to pack the thermite into this iron can. By packing the particles closer together, the heat should transfer better and ignite the neighboring particles more reliably. And here we are. I've put the thermite in a small ball of aluminum foil to better contain it. Now let's ignite it. Now it's going. Interestingly enough, it's not melting through the iron can, nor is the chromium itself melting. There are 2 reasons for this. First, chromium has a somewhat higher melting point than iron. Second, the enthalpy of formation for chromium oxide is slightly higher than the enthalpy of formation for iron oxide. Thus, when we essentially reverse the formation, we need more heat energy to do so. This means there is less heat energy left over to melt the metal. So for chromium thermite, we don't get the molten metal flows like we get for iron thermite. So it's done. I tried breaking this up, but the slag and the chromium particles were too well mixed to separate. This does not seem to be a viable way to get nuggets of chromium metal. Well, there you have it. Chromium thermite. Thanks for watching. If you would like to support the continued production of science videos like this one, please support the channel on Patreon. Links are in the video description.